I'm really an all right guy. My talk is called A Hacker's Guide to Satellites. And by that, I don't mean somebody who wants to SSH into a satellite to take control to plant a virus on it. I mean how to use satellites put into orbit by people like you and me for the use of you and me. I'm going to motor through my talk because I've started slightly late, I think, and there is a satellite that I'm going to tell you about that's, as we speak, winging its way towards our overhead. So I'm going to try and do a live demo using homemade equipment showing how you can listen to what's going on with this satellite. To do that, I'm going to need 2 volunteers from the audience. The downside to being my volunteer is you're going to have to stand up the front, in front of everybody and wave antennas in the air, kind of like that. The upside is I'm going to let you keep the equipment you're going to use so you can take it home and wave it at satellites from your back garden. It's before you volunteer, it's like homemade equipment that looks like this, made out of brass and drain pipes. I shall be using the shop-bought equipment that looks like this. And we'll see who wins. So I've never given this talk before, or indeed used PowerPoint in anger before, so excuse me if it all goes wrong. It's gone wrong already. Oh, fuck it. Okay, the space race began in earnest in, it says here, 1957, when the Soviet Union, as it was then, launched Sputnik 1. Sputnik is Russian for satellite, would you believe? And it took the entire technical resources of the Soviet Union to design and build this thing and put it into orbit. It lasted, I think, 21 days before the batteries died, and then it was up for about a month before it finally fell back into the Earth's atmosphere and burned up. The first private satellite built by people like you and me was launched just 4 years later, called Oscar 1. All privately built satellites that make it into orbit and start functioning are given an Oscar number, and this was the Oscar 1. It was built by amateur radio enthusiasts in America, cost a few $100s, and in fact it was built out of parts sourced from Radio Shack, of all places. What they did was they bought the components they would need in bulk. They tested each one individually to see which was the best and sent the rest back and claimed a refund. And that, ladies and gentlemen, is amateur radio. It piggybacked onto the back of a US spy satellite, and that explains why it's that weird size and shape, and weight indeed, because the spy satellite wasn't perfectly symmetrical, and NASA were balancing the load by bolting some weights in the launch bay. And so the amateur radio enthusiasts found out about this and said, well, if we give you something the same size and shape and the same weight, can we put our satellite on board? And they said yes. And that's pretty much the way that amateur satellites have been launched ever since, piggybacking onto the back of other launches. This $100 satellite also transmitted for 20-odd days, 22 days, before it finally fell back to Earth again. And that was just 4 years after a superpower with their entire resources launched a satellite. Amateur enthusiasts managed to do exactly the same thing with pretty much the same results. So it's quite impressive. This is the state of play at the moment. There's been nearly 90, I think, odd amateur satellites gone into orbit. These are the ones that are up there as of a couple of days ago. This table comes from AMSAT, who are the organization that helps design and build these things. And anyone who's interested could join AMSAT and help design and build satellites. There's 26 operational at the moment, 28 if you count the 2 experiments on board the International Space Station, which I do. And in fact, all of the astronauts aboard the space station are qualified amateur radio enthusiasts. The idea being that on their time off, they can just grab one of the transceivers and have a chat to people on Earth. Yeah, it kind of happens sometimes. Though, in fact, Tim Peake was very, very good at this and did a lot of talking to school children. And so the equipment was actually put to good use. When people aren't chatting on it, which is most of the time, they tend to send back pictures of what's going on the space station or use it as a satellite repeater, of which I will come to very shortly. So the satellite that I'm waiting for, and will be here in about 12 minutes, is Saudi Oscar 50. I said that amateur satellites have an Oscar number. This is Oscar 50. Would normally be called Sierra Oscar 50, but it was built in Saudi Arabia, so it was called Saudi Oscar 50. It's the one on the left, by the way. You can just see it says Saudi Sat 1C above it. There are plenty of pictures circulating on the internet of things that purport to be Saudi Oscar 50, but they're not. That is Saudi Oscar 50. It's about 10 centimetre cube, maybe 20 centimetres long. It was launched in 2002, which makes it very old in satellite terms. Most things that were built and launched in 2002 are no longer working. This is going strong. It's an astonishing piece of engineering. It was built by the big technology institute in Saudi Arabia, the name of which is on there, King Abdulaziz City for Science and Technology. It's in low Earth orbit. That's actually in the last vestiges of the upper atmosphere. In fact, where there is some remnants of the atmosphere left, but there's so few molecules that there's no actual pressure. The molecules are just in orbit around the Earth. It's worth studying it, a place worth studying itself. It travels at about 25,000 miles an hour and orbits the Earth about 15 times a day. So it passes, on average, overhead the UK maybe 4 or 5 times every day, or 4 or 5 usable passes, let's say, that are high up enough in the sky to mean you can actually contact it. Now, on board, there is a satellite repeater. I was talking about those earlier. This is the classic explanation of a repeater, of which there are a lot of terrestrial ones. In fact, there's about 500 in the UK alone of repeaters which just carry voice, and lots more of repeaters that do other things. The classic idea of a repeater is you have a man in a car, a man in another car, and a mountain in between them, because that happens a lot, right? So they can't talk to each other. Their communication is frustrated. They're not unable to tell each other what the weather's like and what equipment they're using. So we put a repeater on the mountain, and lo and behold, car A can talk to car B. The reality is, of course, if you put the repeater on a mountain, it can not just talk to car B, it can talk to the whole area around both the cars. So you would tend to put a repeater in a high point, say in a city, on a mast, or on top of a football stadium, some of them are located, and anyone in the city who has the right equipment can talk to anyone else. It doesn't feed back because you input to it and output from it on different frequencies. So you have to have a radio that can cope with that frequency switching. And in fact, pretty much every handheld radio sold today does have that kind of functionality. So that is a terrestrial repeater, of which I say there are an awful lot. Let me just check if the satellite's overhead. No, we're good. The footprint of a satellite like that would cover a largish city. In London, there are multiples. A largest city could get away with 1 or 2. However, if you put it on a satellite, you're talking a whole different size of footprint. So this is the one we're going to talk to. Well, we're not going to talk to it. We're going to listen to it today. Hopefully. Why on earth did I volunteer to do a live demonstration with homemade equipment? I have absolutely no idea. However, Saudi Oscar 50, it is nearly between 700 and 800 kilometers away. So you can speak to it using small handheld radios, and it retransmits back over an area the size of a continent. So this is the footprint of it when it's sitting over the Mediterranean. As you can see, it covers most of Northern Europe, a lot of North Africa, as far east as Ukraine, some Baltic states, and as far west as out into the Atlantic. So it really is a paradigm shift, putting a repeater on a satellite, and it means that communication over a huge area is possible for somebody who just has a little 25-pound handheld transceiver. So you may be thinking, okay, give me more satellite repeaters. They're obviously a brilliant idea, and I'll run out and get myself a transceiver and talk to the entire world. However, there are a couple of glaring problems. The first is power. As I mentioned before, Saudi Oscar 50 is a 10 centimeter cube, and that means the solar arrays that power it are also 10 centimeter squares. Very, very low power available, so the transmitter on board, the downlink transmitter, has about 1/4 of a watt. That's about as much as your mobile phone, actually not in low power mode, in high power mode. Also, it's about 700 kilometers away, so you can imagine 1/4 of a watt transmitter 700 kilometers away. The amount of radio waves actually reaching the Earth is minuscule, absolutely minuscule. So the solution to that is to use a high-gain antenna, and that's what I have here. It's a Yagi antenna, the same kind that you use in a TV aerial. You can make these at home, or you can buy them off the shelf. You can make them at home, though, for about a couple of pounds. Here's one I made earlier in Blue Peter style. It's made out of 35mm plastic piping with brass rods. It takes a few hours to make it. It's not complicated. And an antenna like that has a gain of around 30 decibels if tuned properly and made properly, which means that in kind of telescope terms, it's a magnification of 1,000. So it's really the minimum you need in order to listen to these extremely low-powered, extremely far-away satellites. So that's problem number one and solution number one. Problem number two, Doppler shift. Did I mention it's traveling at 25,000 miles an hour? I think I did. And as with the racing car, when it goes meow as it goes past, the satellites also go meow in the frequency they transmit down on, and it is a significant frequency shift. So it means when you're listening to it, you have to be constantly adjusting the frequency on your receiver. Luckily, because these satellites are very predictable, we know in advance the speed it's going to be relative to us as it passes overhead. We can figure out the frequency shifts, and we can program them into our radios. So that's what I've done with the little radios here, attached to my homemade antennas. I've used 2 5 kilohertz frequency shifts up and down. And as it goes overhead, I want the happy volunteers to reduce the frequency by pressing the up button. So that's the limit of the technical skill you'll need in order to be able to use these satellites. So that's the solution to problem number two. This is the route the satellite is going to take as it goes overhead today, and I can see it's just broken the horizon. 2:18, what was the predicted time? 2:17, so it's pretty good. It's going to go overhead. Now, this tent is pretty much east-west, according to my iPhone compass, which I hope is accurate. So that's north, that's south. It's going to go north-west to southeast, kind of overhead us in this direction. Now is when I'm going to call for volunteers to come up and help me track it. I will give you a brief 2-minute demo. The first 2 to arrive at the stage get the gig. Brilliant. Perfect. What's your name?
Mike.
Hello, Mike. What's your name? What's your name, sir?
Peter.
Oh, hello, Peter.
Hey.
Right, Mike, you get the plastic piping version. There you are. What, are you right-handed?
Left-handed.
Left-hand. So hold that in your left hand, hold the radio in your right hand. Switch it on like that. Okay, and it should make a loud hissing sound. Hissing is one of the problems of low power work because you hold that. You're right-handed, so hold the antenna in your right hand, hold the radio in your left hand, and it switches on like that. Okay, because the signals are such low power, ordinarily radios turn the speaker off when they don't receive a very strong signal. If we let them do that, we'll never hear anything. So we're going to be hearing a lot of static for the next few minutes until the satellite comes into view. I'm going to be using the shot ball equipment on the assumption that even if these don't get anything, this should. Now, the satellite's spinning in orbit, so we may have to, we're not sure of the orientation of the antenna, so we may have to change the orientation of our antennas as we point. And we're not expecting to hear much until the satellite gets to about 30 degrees in the sky, which it is now. Can you hear that? So we're currently on 436.805. Is that right for you? Is that right for you? The on there should be 436.805. Is that right? So as it goes overhead, when I tell you to, if you press that up arrow key there, don't do it now. So where are we? Come on, satellite. Wait till we get something. This is a static for you all to hear. Can you hear that? We're just hearing the first signs of life from the satellite. What we're listening to is radio amateurs transmitting up, trying to make contacts elsewhere on the footprint of the satellite. So they'll generally be very short. Good. Very short, giving their call sign and their location or some other short bit of information. Okay, if we go up a frequency now, or down a frequency. So it's now just gone through the overhead, actually, so we should be pointing a little bit over here. Are you hearing this? So now the satellite's moving away from us. We need to go beyond the nominal frequency now. So 436.790. Yeah, pointing in this direction now. Yeah.
Roger, 598, Juliet, November, 4, 5, Foxtrot, Whiskey, Roger.
So we're now at the kind of 30-degree mark, at which point we probably expect to lose it with this kind of basic equipment. Okay, thank you very much indeed to both of you. You turn it off like that. There we are. Press and hold the power. Brilliant. And could you give my two fantastic volunteers a round of applause? Thank you very much. You can take this with you and practice at home. Yeah, you keep it all. Okay. Thank you very much. So that is the reality of satellite communications. We've really no idea how good you're going to get on the day, how much you're going to be able to hear. It wasn't a completely overhead pass. Had it passed overhead at 90 degrees, I think we'd have probably had a fairly good signal. It passed over at about 60 degrees. So I think we did fairly well. And actually, the home-built, I don't want to brag, but the home-built equipment did better than the commercially bought equipment. So there, I'm available for parties, bar mitzvahs. I have 5 minutes left, so just enough time to say thank you very much indeed for giving up your lunch hour to come and hear my talk. I hope that's inspired you to get involved. There are actually 2 amateur camps here. One is over in that far corner. They have a satellite station there, a little more sophisticated, with computer-controlled rotators so it can follow the satellites over, and a slightly beefier antenna. If you're interested, go over and have a look, and they'll be able to tell you how to get qualified as a radio amateur if you're interested. It's actually very easy and very, very rewarding and doesn't cost anything. If you're interested in amateur satellite communications at all, your first place of contact should be AMSAT. AMSAT's the American Amateur Satellite Organization, all run by volunteers. They're always looking for people to do almost anything you can imagine, from software to hardware, tracking, demos like this, you name it. So do please get involved if you're as inspired by satellites as I am. And finally, thank you so much for coming, and I'll be happy to take any questions. Here.
Hello.
Hey, what kind of radio are you using? Is it something that can be accessed with like software-defined radio, or do you need some like big hardware stuff?
I'm using incredibly cheap scanners bought from Amazon by a company makes them called Uniden. In fact, when I say incredibly cheap, they're about 50 quid each. If you were to buy something that amateur radio enthusiasts would use for 50 quid, that gets you a full function transceiver with loads and loads of features on. So actually it's not terribly good value. But any handheld FM radio that's capable of being pre-programmed with a few UHF frequencies will do. You don't need any special equipment at all. Just to get the Saudi Oscar 50 and the voice satellites. If you want to, there are a lot of other experiments going on these satellites, and most of them have some kind of telemetry in the downlink. And if you want to decode that and get involved on that side, then a better radio would certainly help. But you can do what we did today with some plastic pipe and a 50 quid radio. The guy over there. It's not going to be when's your next album out, is it?
No. I was just wondering, are there any amateur satellites going up into geostationary so you don't have to wait for their passes?
There are. There's talk of it. There's nothing at the moment, but... oh, is there? Ah, in that case, go and see that man. There is. Ah, okay, yes, that's what I thought. It's first quarter of next year, so it is the next step. Geostationary orbits are a long, long way away, much, much further than low Earth orbit. So there's a whole different set of challenges involved in making satellites that do that. But yes, and that will be an exciting time.
Hi there. Is there much going on in amateur satellite with satellite-to-satellite relaying and sort of setting up mesh networks between low Earth orbit satellites?
Yes, it's been done on an experimental basis. There's been some satellite-to-satellite communication. There aren't enough satellites of the same mode to make that worthwhile. So there's no chance yet of having a permanent, Iridium-style satellite phone network up there. It costs. These days, satellites are a commodity item. You can buy most of the equipment off the shelf. For about £30,000, you can get yourself a basic satellite with a transmitter on, with a board where you can build your own electronics on alongside the pre-built computer. So it's actually a much easier thing to do now. The launch is still the expensive part. Launches typically cost around the $100,000 mark. but still they're few and far between. You have to piggyback on the back of some other satellite mission. So while satellites are getting cheaper, there's still no realistic prospect of getting hundreds of satellites in orbit that you would need in order to do a permanent coverage. Good question, though. That's it. Thank you very much indeed.